Hello all. Today I'd like to take a little time to talk about the challenges I've seen with maintaining Puppet modules, particularly modules for commercial software. The title for this talk is Maintaining Module Manifests, but actually I had 3 other working titles for this presentation. The title could equally have been Automating Automation, or Writing Resources Restfully. Now that should give you a pretty good idea about my downright disturbing love of alliteration, if not about the upcoming perfectly produced PowerPoint presentation. But the third and most provocative option for the title was, why do your commercial software vendors' Puppet modules probably suck? Well, independent software vendors are feeling pressure from customers to support automation tools such as Puppet, and this presents a number of challenges. I work for an ISV myself, and I'd like to share with you my experience in writing a module for Puppet. In particular, I'd like to talk about how a module author might go about making maintenance easier for himself and also improve the end product. But first of all, who am I and why am I here? So my name is Mark Boddington and I work for Brocade as a systems engineer. That means I go and visit new and existing customers and help them use our products in their environments. I work in the software business unit, and my focus is on application delivery controller technology, particular vTM, which is a very clever load balancer type thing, and the VWAF, which is a very clever web application firewall. I'm also a bit of a Puppet newbie. Some of my more interesting customers are in media, e-commerce and gaming, and the reason they're interesting is down to their DevOps culture and their need for automation. Obviously, most of these customers use Puppet and want to automate all of their systems, not just their servers, and that includes their load balancers. So who are Brocade? Brocade are mostly known for their fiber channel technology, and almost all of the big names in SAN are Brocade OEM partners. If you run a SAN and use fiber channel, then the odds are high that you are a Brocade customer. Brocade also have a range of IP networking gear, switching, routing, Ethernet fabrics, etc. What you may also know is that Brocade has a rapidly growing software networking business, building out virtual switches, load balancers, and open source SDN controllers. As I said, I work in that software business unit and focus mostly on the virtual traffic manager, although my remit is likely to expand to encompass more of the SDN and NFV products over the coming months. So why am I here? Our software products, especially vTM, are used by organizations with a focus on DevOps. It's important that we provide those customers with tools to integrate the traffic manager with Puppet. I want to share with you my experience and what I've learned from writing a Puppet module from an ISV point of view. So I came to Puppet Camp Fall, or Autumn, as we call it in the UK, in 2014, with little knowledge of Puppet beyond what it was and what it did. But that event inspired me to start writing a module for vTM myself, which back then was called Riverbed Stingray. Brocade acquired the Stingray product line from Riverbed in March of this year and have subsequently renamed it vTM. There was, and still is, a Stingray module on the Forge, and at first I started looking at embracing and extending that module. But to cut a long story short, the direction I wanted to go in was very different to the way the Stingray module had been developed. So eventually I put it into the too hard box and got on with other work. Puppet is not my day job. So 9 months passed with me doing precisely 0 development on the module. But then I found myself on a Puppet Fundamentals course with the great Adam Buxton. By the way, I highly recommend the Fundamentals course to any other Puppet newbies out there. I think I still might owe him a beer, but maybe he owes me one. Given the fact I've provided some beer hearts and name dropped him in this presentation, I think it's definitely his round. Anyway, the course inspired me to blow the dust off my module and finish it off, this time without trying to integrate it with the Stingray module already on the Forge. So some of you are probably thinking, oh great, so now you've given us 2 commercial software vendors' Puppet modules which probably suck. Well, more about the modules soon, but first let's take a step back and ask, why are we all here? I think ultimately it comes back to this. 3 strikes and you automate. The first time you do something, you just do it manually. The second time you do something, you think, I didn't expect to be here. You wince at the repetition, but you do it anyway. The third time you need to do something, you automate it. Essentially, don't do it once, or automate. So you shouldn't do anything on a computer by hand more than twice. That's what shell scripts are that's what Puppet's for. So don't do it once or automate it. And both of these references go back to 1999. But wait, we didn't use Puppet in 1999. Well, no, but that's because back then you were probably using physical servers for most things, and rebuilding a physical server was a rare event. They were pets. Virtualization and cloud changed the way we deploy services. They turned those pets into cattle. The industry needed a way to deploy services in a virtual form factor, quickly, reliably, and automatically. That's why we're here today. Puppet seems like a pretty awesome way to reliably deploy services in today's virtual landscape. Puppet means we can download modules, write our own, build a few templates and manifests, and then sit back and let Puppet apply our configuration and maintain it for us. Awesome. After all, writing Apache, Nginx, another web server configuration file is tedious. Puppet manifests mean we don't need to, and that's awesome. Writing Brocade vTM or another load balancer configuration file is tedious. Puppet manifests mean we don't need to. Awesome. But wait, there's still a lot of work somewhere, surely. Doesn't the first law of computer jiggerinamics state that work cannot be created nor destroyed, only slopey-shouldered to somebody else? Or Adam Buxton. Sure, Puppet is great for the guys in operations, but someone somewhere is writing these Puppet modules. Are they doing more work or are they doing less work? Now, more importantly, are they doing enough work? Is the module good enough? The theory is automation saves you time, and with Puppet it mostly does, at least when you're a module consumer. But as I said in the previous slide, what about the module authors? If you maintain your own module, have you realized the promise of automation, or are you stuck on the ongoing development treadmill? If you have written a module, then think about the software it configures. Did you cover the basic features and hope that would be enough? Have you ended up adding features piecemeal to the module? Or did you set out to cover everything from the start? Did you get there? Can you keep up with the development cadence of the software itself? If you are maintaining a module for your own software and systems, or even just maintaining a set of manifests for your servers, then that work directly affects your business. That code is of high value and commercial importance for you. It takes the time it takes. It's important. But what about modules maintained by ISVs? An ISV probably has other priorities. A module published by an ISV can often be a best efforts push, and the quality may be inversely proportional to the effort required. An ISV has products of their own to develop and competition to compete with. All ISVs will have keeping the customer happy high on the priority list, but when push comes to shove, a development resource will be put into delivering the next must-have killer feature first. This can lead to 2 related issues. Firstly, the module can lag behind. It can take a long time for new features to appear. And secondly, it can be in a state where only a limited number of features are ever supported. The same is true if you maintain a module yourself or a third party's piece of software. You have the same 2 potential problems. There's going to be lag because you don't know about new features until they're announced or see them until they're released. And depending on the complexity of the software, it could take a lot of work to cover all of the features and functions. Ultimately, authors need more automation for their modules. But how? This is where the original Stingray module and my Brocade vTM module diverge. The Stingray module was too much work. Too much was done by hand, and it was too time-consuming to maintain. At least for my tastes. I am exceptionally lazy. The Stingray module on the Forge supports a very limited set of functionality. You can throw up a simple service, but many of the fancy bells and whistles are unsupported. And guess what? The bells and whistles are the features that our customers actually want to use. The cleverer bit of the vTM was not configurable, because no one had written the manifest for those parts of the system. This was madness. My goal, crazy as it sounds, was to develop a Puppet module which had close to zero maintenance burden on Brocade, and for our customers to have close to zero reliance on Brocade for its use. What can be done? So now I sound like a snake oil salesman. Roll up, get a potent prescribed portion of Puppet's preferred parameter populating potion here. Add all features to all modules or your money back. Guaranteed to make your toes curl and put a smile on your face. But actually the clue to the magic was in presentation title number 3. Writing resources restfully. Back in 1999, again, a good year obviously, some clever folks at the W3C devised the REST architectural structure. Today, RESTful APIs are everywhere, and this architecture is actually exactly what we need. REST services, by their very nature, are discoverable. I can find out what services are available by simply probing or walking the API. So let's take a relaxing ramble through the vTM REST API. This is the top level of the active configuration tree for a typical vTM. REST dictates that resources should contain links to reference state and links to reference-related resources. In the vTM API, the top of the configuration tree is here. As we can see, this contains only children, and each child here has a name attribute and a link attribute. I could have started at REST and at the root and walked down to this point, but this is really where things get interesting. So if we follow one of these paths and go into, let's say, virtual servers. In here, we can see again a list of children, but this time these links are to actual virtual server objects, as we'll discover in a moment. So taking a step down, let's go into our finger service. So finally, this is an actual virtual server configuration object. In this case, it's for a finger service. Look at all of those options. Can you imagine writing a module and maintaining the module to handle all of those options by hand? Well, this is the raw JSON, and this is a slightly prettified version using a Chrome extension. Properties returned by our API are in a JSON structure, but XML is also used by some APIs. But the important thing is, it's very easy to consume this structure programmatically. And what can we do if we can consume something programmatically? Well, we can get a computer to do it. We can automate. So there's no reason that you can't automatically generate Puppet manifests for anything that has a REST API. By the time you write your third manifest, shouldn't you be already looking for a way to automate it? If the software you're automating has a REST API, then it should be possible to generate manifests automatically. This manifest on the screen now, that wasn't written by hand, that was written by a script. A quick crude example. Walking a vTM version 9.9 REST API results in 91 manifests. If I walk a 10.1 REST API version, I get 93 manifests. That's 2 completely new configuration objects. And that's not counting lines of code, that's not counting how many features may have been added to objects which already existed. But because we walk the API and generate the manifest programmatically, as soon as a feature is added in the traffic manager, it can be made available to Puppet. So what are the benefits? Well, zero maintenance modules. It's easy to support new versions of the traffic manager. I just rewalk the API and generate new manifests. No feature lag. All new features are released with REST API support. This means they have Puppet support too. Full feature parity. Currently our API is not quite 100% coverage, but it will be, and when it is, so will Puppet. Another nice feature of this is do it yourself. Because I generate these manifests automatically, I provide the tools with the module. So our customers can build their own manifests for their version of the software, whether that's a past version, the current version, or a future version. There's no reliance on the vendor, no reliance on Brocade to make updates to the modules. But hang on, if I can walk the API and generate classes and definitions for use in the vTM module, then I can walk your API of your vTM and generate a specific node configuration for your traffic manager. A tool to do that is also included in the module. Do you still write your node manifest by hand? That's tedious. So about time for a demo. So the module on the Forge, Tux Invader Brocade vTM. And in there we include tools. There's a gen manifest for generating the Puppet manifests by walking the API. There's gen node config to generate node configuration from an already pre-configured traffic manager. And then update docs and cleanup are supporting tools for those two things. So there's two demos you can have a look at, and you'll see that in action. So what's the downside? Well, it's difficult to do input validation using this technique, at least beyond basic types. But shouldn't the REST API be doing input validation? If you submit invalid data to the API, then the RESTful service should return an error. Is that slopey shoulders? Maybe. You can't generate manifests to make use of virtual exported resources just by walking the API. It's not obvious that something makes sense as an exported resource. But there's nothing to say you can't put code in your scripts that walk the API to say, yes, this is a pool and it contains nodes. Nodes are good candidates for exported resources, and just handle them differently. It doesn't mean you lose the automation of the manifest generation. It just means you know to handle those differently. It would be nice if the module supported per object configuration and also high-level application configuration, like templates for specific applications. Yes, it would, but you said and. First rule of Puppet Camp is if you said and, it's a different module. So yes, that would be nice, and it is something I'm working on. And when it is published, it will use the automatically generating modules as the tool to deliver that. So yes, no argument there. So what code did I actually write? Well, I wrote a custom resource type and provider called vTM REST for talking to the vTM API. I wrote the init PP for the class, and I wrote a purge PP manifest to allow us to have file purge type behavior in the vTM. So if you enable purge on your traffic manager config, then if we discover configuration that you haven't explicitly configured in your Puppet manifests, then it will be deleted. And of course I wrote a few Ruby classes to walk the REST API and generate the manifests themselves. So I think that's as close to zero work for maintaining module manifests or automated automation as I think I can get. And it's all thanks to writing resources RESTfully. Remember, the same manifest generating technique can be applied to any software or service with a REST API. Thanks for listening.